All right, guys, today we're going to be learning about Newton's second law. Newton's second law is super simple because it is just a mathematical equation. That is all there is to it. So we'll go ahead and start off by writing that mathematical equation at the top. Newton's second law states, formula-wise, that force is equal to the mass of an object multiplied by its acceleration. And that is Newton's second law. I mean, if you think about it, this is really not bad. Newton's first law is a word, inertia. His second law is an equation, F equals ma. Now we're going to review a couple ideas here. We're going to start with the idea of acceleration because you have to be able to figure out the acceleration so that you can figure out the force at which an object is moving. And that's the whole reason we took time to learn about speed and acceleration is for this moment. Acceleration is nothing more than a change in motion or in an object's motion. Let's do that. Now remember, we often think of this being speeding up, like this guy here, speeding up, or slowing down. But it can also be a change in direction. If you ever want to think about, like, trying to remember what are the different things in acceleration, think of a roller coaster. That's acceleration. Roller coasters are speeding up, changing direction, slowing down. So let's dig a little bit deeper and take a look at what this means in our world. The greater the mass of an object, or the greater the object's acceleration, the greater the force. All right, so pretty much what we're looking at here is that if you mess with the mass or the acceleration of an object, you will increase the force. And that force can be something getting it to move, something slowing it down. It can be any type of push or pull. One of my favorite events at Ball State, every year they would have this spring watermelon festival. And one of the favorite events was you had to get with a group, like somebody else, and you had to carry a greased watermelon 100 yards. Now, let me tell you, you may not think that sounds difficult, but a watermelon actually has a pretty good mass. And when you put grease all over it, there is no friction helping you hold it in your arms. So the force at which gravity was pulling that watermelon down was pretty decent, and you had a hard time sticking to the watermelon. There was a rare occasion where somebody actually made it to the end of the line with a watermelon that had not been crushed by falling to the ground. Okay? Would have been a lot easier if that item would have been an apple, because the gravity would not have been able to pull with as much force on that apple. Well, it would have pulled the same, but the force of the item being pulled down, or the force at which it would have felt on the person carrying it, would have been less. Let's take a look at another couple examples. Let's look over here. This guy's wondering which is harder to stop. This giant boulder or this tiny little rock? Well, any common sense person will let you know that that rock is going to be a lot harder to stop. Why? Because it's got mass. It's got a much greater mass. It's going to be rolling down the mountain with more force than the tiny little rock. Let's look at another way that mass can affect these things. Trying to get the acceleration of something up. We all remember being little kids and taking our Matchbox cars and pushing them across the ground and inevitably hitting some poor parent as they walk through the kitchen. They get a little like Matchbox car rammed into their foot. If we look at these two different situations, we got a guy with a Matchbox car and then a guy over here with a large truck. Okay? This guy is saying this is hard because he's trying to push a massive truck. Getting it to move or accelerate is difficult because the mass is so great. When this one is easy, because the mass is small, getting its acceleration, you don't have to put nearly as much force into it. The greater the force applied to an object, the more it accelerates. The harder you push, the more something will accelerate. That's kind of obvious, I think, too. But how easy it is to get to accelerate depends on its mass. Now, at this point, we've taken our notes. That's pretty much all you have to take notes with. I'm going to give you a couple more examples of how force, motion, and acceleration come into play. And when I do this, I'm going to be using the letters themselves. And the size I write the letters will help determine how great they are. For example, if I write a big M, that means something has a large mass. If I write a tiny m, it has very little mass. If I say a big A, lots of acceleration, tiny a, very little acceleration. You guys good with that? Can we understand? Okay. So on Sundays, going to Myers, Henrik. I'm calling it Henrik Cam because they're both not focusing. Thank you, guys. That's on video. When I go to Myers on a Sunday, it is a madhouse of usually yelling and screaming kids and panicked parents trying to collect all their groceries before the beginning of the week. Okay? This is why Mr. Hamlin goes shopping on Friday, because it's a lot easier. All right? Now, when I get there, if I go on a Sunday, I almost every time get hit by a shopping cart. It's a guarantee when I go. Some poor mom with like 3 kids trying to keep her kids happy because evidently dad's decided not to take care of them for her. She's swerving around a corner and slam into me. Now, how much this hurts depends on one key factor. How much she's carrying in her cart. So if we look at a full cart would have a fairly large mass, a fairly small acceleration because not many of the people are running around at full speed. Therefore, I'm going to get hit with a medium force. But if I'm lucky enough to find an empty cart, then the mass is going to be small, the acceleration is going to be small, and the force will be tiny as well. So mass makes a difference. Acceleration makes a difference. I'm going to use an extreme example. Let's take a look at a bullet. A bullet is a tiny object, usually a couple of grams in mass. It has an incredibly small mass, but what makes a bullet dangerous is not its mass, but it's what? It's acceleration. A bullet literally goes faster than the speed of sound. That's what makes a bullet dangerous. It's acceleration, which gives it a large force. Likewise, another extreme example. If I dropped a bowling ball on your toe, right? Okay, so I learned that there are some words that are bad to say. When I was about 5 years old, my dad, who was a Methodist pastor, so a man of the cloth, a religious man, right? He said the S word in a very loud manner inside of our kitchen. As a little child of 5, I freaked out. My dad, the preacher of the local church, just said the bad 4-letter word that begins with S. I'm only 5. My world's been turned upside down. This is where I learned that sometimes those words slip out. For this is what happened to my dad. He opened up the freezer, and my mom was very conscious of money because we didn't have a lot, so she would buy things when they were on sale and freeze them. Well, they had a sale on chicken. Believe it or not, kids, when I was a kid, you couldn't go to the grocery store and buy chicken breasts. You bought a whole chicken or you didn't buy a chicken. So I walked in, my mom went to the grocery store, she bought like 3 chickens, and she decided to freeze them in the freezer. Well, back in those days, we didn't have side-by-side freezers. The freezers were all above the refrigerator section. My dad, being my dad, God love him, decided it was time for a little ice cream that night. He opened up the freezer to get the ice cream out, and a frozen chicken rolled out of the freezer, dropped 3 feet, and landed on his big toe. This is where my dad taught me, you can say a bad word, Chris, if a frozen chicken falls 3 feet on your big toe. Otherwise, I don't want to hear anything like that out of your mouth. The point being, did that chicken have massive speed? No, what did it have? Mass. And it squashed his toe like a ripe melon. So, in that case, we have a large mass, a small acceleration, a big force, and my dad yelling, ouch. No, he didn't yell ouch, but he yelled something. Okay. So, what affects the force of an object? Either to move it, to stop something from moving, or to keep it going? It's all about how fast do you want it going and what is its mass. All right, let's get them glued into our science notebook, guys.